Okay, this is organic chemistry, advanced A level. So we are dealing with the organic chemistry, whereby that is just a branch of chemistry, and we are studying compounds of carbon and hydrogen mainly. So what we are going to be looking at, it is carbon and hydrogen. How does it behave? Then if it is hydrogen and carbon, it means that they are bonding. So what makes carbon to bond with hydrogen? There is a certain uniqueness when you go in the periodic table, whereby that carbon falls under group 4 elements. So when it is falling under group 4 elements, it is the one which is the first, and it is having certain characters which don't resemble lead and other compounds which are in group 4 elements. And the first one, that is the one with the smallest atomic radius. So this smallest atomic radius, it will make it able to bond. Then it is the one with a high electronegativity, whereby that electronegativity is just the tendency of accepting electrons from other atoms as you are doing a covalent bond. Then there is also formation of multiple covalent bonds by itself, whereby that we say carbon to carbon. Then and it can form those bonds, the other multiple bonds with other elements. As you look at carbon when it is bonding with nitrogen, with triple bonds. These bonds are called covalent, and carbon mostly does it more than those group 4 elements. See, it can bond with oxygen, as you have seen here, and many others. And again, it is having an ability to form long chains of identical atoms, and that the ability for that atom to form long chains by itself, we call it catenation. The good example I can give you ethane, whereby that it is CH3. This is the long chain between a carbon and another carbon. Even butane can do that. Butane, when there are 4 carbon atoms, CH2, then CH3. Then since this is a new branch of organic chemistry, there are some terms we use to talk about organic compounds. Then we have homologous series, whereby that these homologous series, those are compounds whereby for them when they are closely related, because they have a similar chemical property. So these compounds, they are having a similar chemical properties, whereby that the behavior of the other compound is the same as the behavior of the other compound. Now when you look at butane, which is with the 4 carbon atoms, will be the same as the other ethane, which is the 2 carbon atoms. So these ones, they are having similar chemical properties. As you are seeing that we say that these alkanes, they are always saturated. So if it's like that they are having similar chemical properties, what makes them to have similar chemical properties? Due to these characteristics, that when you are preparing them, you will see that you use the same general method, whereby that when you are preparing this, you use the same general method. You will not use any other method when you are preparing. For example, when you are preparing methane, you will not use another method, but that method will be the same as you are preparing ethane. Then again, they have the same functional group, as we have seen that they are having. These ones are they are single bonded. So you will not find that they are having a same functional group that they are having. Others are having double bond, others are having single bond. They will only be with a single bond. Then they will be with a similar chemical properties as in the definition. But the only difference is it will be their physical properties, such as melting point and boiling point. Why? Because when you look at them, you go on adding carbon atoms, and whenever you are adding carbon atoms, that addition of carbon atoms increases their molecular weight, and that molecular weight is the one which determines the boiling point and the melting point and the boiling point. Again, when you look at them, when you try to count the number of carbon atoms and hydrogen atoms, you will see as if they are having a same general formula. As you are seeing that, if let us say if there are 2 carbon atoms, you will see that this one now will be, it will be times 2, then plus 1. And you will see that if it is ethane, it will be like that. Then and other compounds, the formula will remain the same. Then if we go for the second, if we go for the second key term, we are going to look at an alkyl group, whereby that sometimes they write it as letter R. Now, this alkyl group, those are hydrocarbon, whereby hydrocarbon, these are compounds with hydrogen, with carbon and hydrogen. Now, these are hydrocarbon, whereby that they are having one hydrogen atom less than the usual alkane. But the number of atoms, of carbon atoms, remain the same, but we shall subtract one hydrogen atom to the corresponding alkane. Now, the good example is methane. Methane, it is CH4 with 4 hydrogen atoms. But remember, according to the definition, that we shall subtract one hydrogen atom. So it will become CH3, whereby that we shall say methyl, whereby where there was a suffix of AN, we shall add YL. Now, if we look at ethane, the number of carbon atoms remain the same, but we shall subtract 1. So we shall AN, we shall put there YL. Then another key term, it is the functional group. So what is the functional group? Those are just a group of atoms with most reactive parts of a molecule possessing weak bonds that determine the chemical properties of homologous series. Remember, homologous series, we say that those are compounds which are closely related and they have the same chemical formula. They have the same chemical properties. Now, we have talked about possessing weak bonds. But where is the weak bond? The good example I can give you, it is ethene. When you look at ethene, these are the bonds we are talking of, between a carbon and another carbon atom. Now, these are the weak bonds they are talking of. That it's a group of atoms with most reactive part of a molecule possessing weak bond that determine the chemical property of homologous series. Now, these weak bonds, they are the one determining the chemical property, whereby that either they are the one to allow in a molecule to enter, or they can deny it. Now, when you look at alkenes, all alkenes, they are unsaturated. All these double bonds, they can allow additional reactions. So those are the first key terms. And as we have been talking about bonds. Then we need to talk about the nature of bonds between carbon and carbon or other atoms. Now we have types of bonds, and the first bond, it is the sigma bond, and it is noted by this symbol, sigma. Now, sigma bond, those are just strong covalent bonds with localized electrons concentrated along a line joining two nuclei. Now, the good example I can look at, it is the carbon and another carbon. This single bond, this one, it is the one we are calling the sigma bond, because it is the one joining the nucleus of this carbon atom to the nucleus of another carbon atom. So, this means that this line, they are making that line and they are concentrated towards making this one to be joined onto this one. And they are telling us that they are localized, that they are allowed to move or permitted to move from this carbon atom to the other carbon atom. Then again we have another form of bond. We have a pi bond with this format. Now this one is just formed as a result of subsequent overlap of anhybridized 2p orbital. Now, if we talk about 2p orbital, remember carbon has 6. It is over 6 atomic radii. So, if we try to write its configuration, it will be 1s, then 2s, then 2p2. This is what we are talking of. That it is result as the formation of subsequent overlap of unhybridized 2p orbit. Now the hybridization just means mixing of electrons from another energy level to the other. Now, if they add a word that unhybridized, it means that there was no mixing of those electrons. Now here, that they are unhybridized, these p electrons, they failed to mix with these ones. So, as they are there, they will form this format of bonds when they are bonding with other atoms. So, those are the pi bonds. And now they are telling us that these electrons are delocalized since they move freely throughout the orbital between the two carbon atoms. Now, if we consider this one, the pi bond here, let me take that this is now the pi bond. It will be delocalized. That now for it is free to move. It's not like for the other, the sigma bond, that for them they are limited to move just from this to this. Now these ones, they are able to move either from up to down or to any side. So those are the sigma bonds. And a good example of the pi bond, and a good example of pi bonds, that is the double bond and the triple bond. Now if we consider the double bonds, in the double bonds we have both the sigma and the pi. The first one joining the carbon to carbon, it is the one which is the sigma bond, because it is concentrating, or it is making this one to be strongly held with this one. So it is going to be, its electrons are going to be highly concentrated towards that line of joining, from this nucleus to the other nucleus. Then this one is going to be free to move as by definition, so we shall call this one a pi bonds. Now if we consider triple bonds, these two electrons, after having the sigma bond which is making this one to be strongly held covalently by a sigma bond, these two remain when they are pi bonds, because they are freely to move, so they are delocalized. So if we still continue, they are available for additional reaction, addition of hydrogen chloride to alkenes. Now if I consider my alkene, which I had already written here, and I say that I'm adding hydrogen chloride, this one can be simple, because this electron, it's as if this electron, we have said that it is free, it is delocalized. So it can move and pick this hydrogen ion. So this means that this can allow additional reaction, so that they are available for additional reactions.